Yes, it's 9:01. Yes, good morning, students. We are into the second part. In the last class, I thought of going ahead with this, but due to certain interruptions, I could not move ahead. So, in the first part, we had the complete fundamental concepts, starting with the definition of artificial intelligence that were proposed by various famous authors. And then we had a glance at intelligent systems, and then we had a glance at ELISA, one of the first of its kind intelligence system. And then we have gone at the applications of AI, the history of AI, and then finally the uh, the current trends in AI. That was the backdrop, and with that uh, backdrop, let's move ahead to the concept of problem solving and control strategies. This concept is important. This concept is important. So how do we solve problems? Let me see how many of the students joined. I do have 24 students. Ma, CR, Meghna. I'll move ahead.
Sir,
I'll move ahead, Amma.
yes, sir.
I do. Yeah, okay, thank you. Yes, let's go with the general understanding of problem solving. See, suppose if I ask you to write down a simple program to check whether a number is prime or not, what would be your approach? How do you solve the problem? To check if the given number is prime number or not. It's a simple problem, which does not require artificial intelligence. You can use your fundamental concepts. How do you approach to check whether the given number is prime or not? The simplest methodology we follow is we'll find the number of factors because we know the definition of prime number that one and itself only it gets divided by. So then if the number of factors is equal to 2, then we say it's prime number or else it's not a prime number. That's a simple way of doing it. So our objective is to find the total number of factors for that number. And if the total number of factors is equal to 2, we simply say that it is a prime number. That's the simple notion we go with. So that's the procedure we employ to find. That's the way we solve the problem of finding out whether the given number is prime or not. And at the end, what is that you're doing? You're checking whether the total number of factors is equal to 2. So that's the control strategy you're using. After finding out the number of factors, it's not simply finding out the number of factors. You are applying a control strategy also. Based on the control strategy, you're determining whether it's a prime number or not. So that's a simple problem solving for what is this the prime number. In the similar sense, you might have come across with several problem solving the concepts in first year C language, solving various types of problems. So all those are simple problems. Now let's try to increase the difficulty level of the problems where artificial intelligence will play its role. Okay, so problem solving is the method of deriving solution steps, a step-by-step procedure, beginning from initial step to the desired state. So that's what problem solving is. And this is one of the important areas of the artificial intelligence, and this can be characterized through a systematic set using a range of possible steps, possible steps. And if you follow these possible steps, definitely you come across with a solution. So it is deterministic. There could be certain cases which is non-deterministic also. Here we are going with deterministic concept. So, and the problems are frequently modeled as state space problem. See, why are we calling it a state space? See, there will be several possibilities. This is one method I've told you. So, in that particular method, there are several possibilities. So, that total set of possible states, we normally call it as state space. The total, say, suppose if you say, if you are playing chess game, hope most of you are aware of the way of playing chess game. See, if the opponent makes a move, what would be the possible steps that the human being and the other opponent will make? See, there will be several possibilities. If you can pick out all the possibilities based on the other party's state, that is called as and the possible states. That possible states is nothing but called as state space. You can apply this to any kind of problem. You can apply this to any kind of problem. So, and in this possible set of states, you will have the starting state to the ending state. That's your goal state. That's what problem solving is. So, and there are two types of problem solving methods. So one is general purpose, the other one is special purpose. See, when I say general purpose, it can be it can be applied for a variety of problems. Whereas if it is special purpose, it's going to meet the need of a particular problem. So that's the reason we call it as tailor-made for a particular problem. So you can go with so this special purpose will meet only the need of that particular problem. So that's the reason when you are asked to write down programs, you will be asked to write down generic programs. That means, suppose if I say I want to find the sum of two numbers, it should not be calculating the sum of only 10 and 20. And whenever I run it, it should not be giving me the sum as only 30. Suppose if I provide different values, it should be able to give me the sum of those two values also. So that would be called as generic. That would be called as generic. Suppose if I say test whether the given number is prime or not, you should not be writing down a program to test only whether 7 is prime number or not. Given any number, your program should work. So you should make it more generic. That's what you mean by general purpose method. If I do it only for 7, that is special purpose. It only works for 7 only. Okay, so the most general approach for solving a problem is to generate the solutions. That's what all possible states, possible states, which we normally call it as the state space, and then move ahead. Apply those steps that are available in the state space and try reaching a solution. So you will always start at an initial state and then apply the rules that you have defined, the states that you have defined, which could be a simple action or it could be an operation or it could be any rule. See, for prime number, what is the rule we are doing? If the number of factors is equal to 2, that's the rule. Then only we say that we have reached the goal state, that is, it's a prime number, or else it's not a prime number. So that's how you move ahead and test whether the state is the goal state or not. In the case the state is not the goal state, the procedure is repeated. See, this application of the rules, this application of the rules to the current state, we normally call it as the control strategy. That's the reason the concept is problem solving and control strategy. Okay. So you will have a set of rules and you need to apply those set of rules to the current state such that you move towards the next state or a goal state. The next state could be a goal state also. So that we normally call it as the control strategy. So these are two concepts combined together, problem solving methodology with the application of control strategies. So general problem solving. For general problem solving, we normally go with the production system. The production system is nothing but a set of rules, in call it as in the simplest sense. So production system is one of the formalisms that helps AI programs to apply the search process more conveniently in the state space problems. That means you will have several states, you will be picking up the necessary state that is applicable to your problem and move ahead towards obtaining a solution. So definitely this particular production system will have an initial state and the goal state of the problem. Along with that, it will have certain intermediate states also. The intermediate states also there. So the system comprises of start, that's the initial state, and goal, the final state of the program, along with one or more databases consisting of suitable and necessary information for the particular start, certain background information, just to apply the solution. So, sorry, just to reach the solution. See, the production system, the PS, consists of a number of production rules. This is the control strategy. A number of production rules in which each production rule has left side that determines the applicability of the rule and a right side that describes the action to be performed. So the left side of the rule specifies what action are you going to, what test are you going to, what condition are you going to check. and the right side of the rules tells you that this is the action that is going to be performed. Just 1 second, Amma. Please hold on. I'll be joining you in just 5 minutes. Okay, Amma, CR?
Yes, sir.
జస్ట్ ప్రిన్సిపల్ గారు పిలిచారు, వస్తాను మళ్ళీ. Hello, hello.
Yes, sir.
Sorry for the inconvenience, Amma. I've just now come back. I'll continue with this. Say the production system will consist of a number of rules, and these rules will be applied to arrive at the solution. So normally we'll be specifying the rule. See, when I say rule, you'll have a left-hand part and the right-hand part. That is antecedent and the consequent normally. If then, if you map it to a programming language, you may call it as if then rule. So if the condition is satisfied, then the action will be taken. That's how it says. The left side that determines the applicability of the rule. If the rule is applicable, that is if the condition is satisfied, you'll be performing the necessary action. So that's what a production rule is. Okay. So, and the production system can have several control strategies. See, the production system is going to have the control. See, how to apply it? What is the sequence to be followed? Which rule is to be applied to arrive at the solution? So, for a particular problem, you can have different types of solutions based on the control strategies or based on the application of the production rules. So, production rules are being part of the production system. See, the advantage of production system is it's a good way to model the strong, straight-driven nature of intelligent action. That means if you have this production system, see, you'll have certain predefined set of rules. So based on that particular rule, what we do is, if the rule is satisfied, 100% that action can be taken into consideration. That is one advantage. Suppose if the new rules are to be added, yes, you can happily add new rules to the existing part. Suppose the existing set of rules are not sufficient to arrive at the solution, then you can add new rules to this existing set. And in real-time applications, it is quite important in real-time environment and applications where new input to the database changes the behavior of the system. See, now we are coming out with a solution with the current set of inputs, states. See, when there is a change in the inputs, see, you look at your cricket game. See, when 40 years back or 50 years back, we used to, in a one-day game, we used to have 60 overs. But do we now have 60 overs? It's only limited to 50 overs. And there are several rules that have come into picture. All those would be the inputs. All those would be so according to the input, the behavior also, that the game strategy also changes. That you might have observed. All those people who are good at watching cricket or playing cricket, you could be knowing this. See, earlier we used to have only first 10 overs as the what is this, where the limited number of players will be outside the 30-yard circle, and there are certain field restrictions. Now that you will have three parts, you have three parts, 1 to 10, 11 to 20, and last 10 hours or something like that. So those are the inputs that are going to change, and accordingly the game strategy changes, the behavior changes. That's how you can map it to the real world problems. Okay, look at this, a very, very interesting and simple game which has been in existence for in artificial intelligence since longer. Anyone who teaches the problem solving strategy in artificial intelligence will discuss this problem. This is called as water jug problem. And in water jug problem, we normally have two water jugs. See, the capacity of the water jug is given over here. One consists of 5 gallons of water, the other one 3 gallons of water. And though these water jugs do not have any markers, it will not have any markers. If it is filled up to this one, it is 1 gallon. If it is filled up to this point, it is 2 gallons. If it is filled up to this point, this is 3 gallons. Those markers will not be there. The measuring markers will not be there. And the water supply is there. Continuous water supply is there. So you can use any amount of water, but you have two capacities, two jugs with two different capacities. One is 5-gallon capacity, the other one is 3-gallon capacity. Without any measuring markers. Please remember that, without any measuring markers. Now, what is your task? What is the problem? The task is to get 4 gallons of water in the 5 jug. In this particular one, the ultimate solution should have 4 gallons of water. See, if I have a marker over here, then I don't need this jug at all. I don't need this jug. Based on the marker, I can simply fill up to 4 gallons up to that marker. So you are given 2 different gallons of 2 different sizes, 2 different jugs of 3 different gallon sizes, and now the objective is to the goal is to fill this 5 gallon jug with 4 gallons of water. See, the solution could be quite simple, but that should be very generic and applicable to various solutions. Suppose if I change the size of the gallon and jug, then also it should be applicable. So let's try to give a solution for this using the production rules or the production system. See, what could be the state space for this? Let's assume that there are two integers x and y, where x represents the state of the water in the 5 gallon jug, and y represents the state of the water in the 3 gallon jug. So x represents the quantity of water in the first jug, y represents the quantity of water in the second jug. So what is the starting state? Both the jugs are empty, that is 0, 0. What should be your final state? The final state says that in the first jug, that is in the 5 gallon jug, you should have definitely 4 gallons of water only. And in the second jug, you can have any amount of water. You can have completely 3 gallons of water or less than equal to 3 also. We are not worried about it. See, that's the reason we have written it as n, where n is less than equal to 3. So this is the starting state and this is the ending state. This is the ending state. So this is how you have to define your problem. See, this is the problem given to us. This is the objective given to us. Accordingly, we are trying to specify the state space problem, the state space for this problem. So what are the various possibilities that could take place? So what is the problem? So the possible operations, these are some of the operations that you can see. Fill the 5 gallon jug from the tap. Filling is one state, empty is another state. Fill the jug is one other state. Empty 3 gallon jug, again this is another particular state. Pour some water or all 3 gallons of water from 5 gallon jug into 3 gallon jug. That is also another kind of state. Pour some full 3 gallon water into 5 gallon jug. So these are different possible states that could take place. So different possible states that could take place when you try to solve this problem. All these steps we normally call them as production rules. We normally call them as production rules. So let us see. So here we have defined 8 set of rules. 8 set of rules. See, this is very clear. The rule number is given. The left side of this is antecedents. That's the if part. The left side of the rule. This is the then part. That is the right side of the rule, and the understanding part. That's the description. So the initial, what does x and y represent? X represents the state of water, the quantity of water in the first jug. Y represents the quantity of water in the second jug. So x is less than 5. X is less than 5. That means it could be 0, 1, 2, 3, 4. So when I say 0, it is totally empty. Now, see, if this is this, what is that we are trying to do? The right side of the rule. See, when x is less than 5, you can fill the jug. So, and make it 5. So, what will be the action part? Now, the jug will have 5 gallons of water. So, what is the description? What do you understand from that? Fill the 5 gallon jug with complete to its brim. That means it will be completely having 5 gallons of water. Now, let's look at the second rule. Look at it. When the gallon first jug has some water. So greater than 0 means at least it has certain 1 gallon of water. So if it has 1 gallon of water, I'm making it 0. Now what does it imply? I'm throwing away that water. So that means what's the description? Emptier. You're vacating that particular jug. You're totally making it empty. So what is the left side part of the rule? X comma y and x greater than. Look at this, x comma y. You have to understand these rules. This is important for the production system. X comma y and x is less than 5. You are trying to fill the jug to its complete level. That means you are making it to 5. X comma y, you are trying to throw away all the water. When can you throw away all the water? There should be at least some amount of water. That's the reason we say x greater than 0. Now, the same in the similar sense, you are trying to fill in the y jug, that is the second jug, x comma y, y less than 3. That means there is some space left over, which can be filled with few, few more gallons of water. So you are trying to fill in the second jug. So you are filling the 3-gallon jug. Now you want to empty it. So if it emptying means it should have some amount of water. So that's the reason we say y greater than x comma y such that y is greater than 0. Then you can empty it. That is the description is empty 3-gallon jug. This is how the rules are defined. You have to understand these rules and you should be in a position writing down your own set of rules also for any given problem. So x comma y, look at this, the left side part of the rule. X comma y, x plus y is less than equal to 5. What do you mean by that? You are pouring the water that's available in 3-gallon jug into 5-gallon jug. You are pouring the water available in 3-gallon jug into 5-gallon jug. So x plus y less than, how much water you pour? Only to its level only, 5 gallons. So the sum of the total sum, if there is some water available in the x-gallon jug plus the water that is poured from 5-gallon, that is the second jug into this, should be less than equal to 5 only. And when can you do that? If there is some water in the second jug. That's the reason. See how is it in x comma y such that x plus y less than equal to 5 and y greater than 0. What does it imply? You are trying to pour the water that is available in 3-gallon jug into 5-gallon jug. So thereby what is happening? The second jug is becoming empty and the first jug will have the initial water that's available in first jug plus the water poured from the second jug into the first jug. That is x plus y. That's the right side part of the rule. Similar way, see this one. That is from this side to that side. That is from first jug to second jug. X comma y. X plus y less than equal to 3 and x greater than 0. That means you are trying to pour the water from 5-gallon jug to 3-gallon jug. So what will be the condition? There is some water available. There is some water available in this, or there is no water available in the second jug. You are trying to pour the water that is available in the first gallon jug into the second jug. So x plus y less than equal to 3 and x greater than, there should be some water available. So thereby what are you trying to do? You are trying to make it empty. So, and now the second jug will have the total quantity as x plus y. That is initial quantity y and new quantity x. So empty 5-gallon jug into 3-gallon jug. So look at this condition. X comma y. X plus y greater than equal to 5. X plus y greater than equal to 5 and y greater than 0. What does it imply? You need not read this description. It clearly says that you are trying to pour water from the second jug, that is 3-gallon jug, into 5-gallon jug. So, and what is the maximum capacity of that? 5 only. So you are trying to make the first gallon jug as 5, and whatever amount of water that you have poured from the first second gallon jug into the second one, that is 5 minus 6, y minus 5 minus 6 will be this. That's the remaining amount of water available in the second jug. See, look at this. Until the 5-gallon jug is full, that is pour water from 3-gallon jug into 5-gallon jug. The same way, in the similar sense, now you are trying to pour water from the first jug, that is 5-gallon jug, into 3-gallon jug. See, x comma y, x plus how much water you can pour into the second jug? Maximum 3. So that's the reason x plus y greater than equal to 3 and x greater than 0. See, these definition of rules are important. These we call them as production rules. This description is only for our understanding purpose. So when you are asked to write down the production rules, this is for a given problem. This is how you have to frame the production rules. And these 8 production rules are defined for our water jug problem. Okay, that is 5 liters water jug and another 3 liters water jug. Now you have to apply these rules from the starting state and in order to reach the goal state. See, there can be different solutions. Do not go with the wrong notion that there is only one solution. So what is the initial state? Both the jugs are empty. Both the jugs are empty. Now, and that's the initial start state. Now I am applying rule number 1. What is rule number 1? Just now we have seen, see. Fill the 5-gallon jug. So what will be the right side part of the rule? 5 comma y. So when I fill the 5-gallon jug, the quantity of water that's available in 5-gallon jug is 5 and the 3-gallon jug is 0, and this is the step number 1. And the rule applied is first rule. Next, see which rule is being applied. 8th rule is being applied. What does 8th rule say? You are pouring water from 5 gallon jug into 3 gallon jug. That means this part. So what happens? See, the second jug can have the capacity of 3 gallons of water only. So you are pouring water from the 5 gallon jug to 3 gallon jug. So you will be pouring 3 gallons of water into the second jug, and 2 gallons of water will be remaining. See, this is according to this eighth rule. See, x minus 3 minus y, comma 3. This will be filled up. This will be filled up, and the remaining water will be available in the first gallon jug. That's the second step when you applied eighth rule. And then applying the fourth rule. What is the fourth rule? X comma y greater than 0. That means you are emptying the second jug. See, these 3 gallons of water will now be emptied. That is step 3. Next, which rule is being applied? Sixth rule. What does the sixth rule say? What does the sixth rule say? You are emptying the 5 gallon jug and pouring that water into 3 gallon jug. Now, what does it say? See, sixth rule, we are making this a 0, and the remaining, the water that's available in this 5 gallon jug, how much water is available? 2 gallons. Thus, 2 gallons is placed in this. Next step, what is the rule number 1? Again, rule number 1 is being applied. What does rule number 1 tell you? What does rule number 1 tell you? You have to fill the 5 gallon jug. Yes, I am filling the 5 gallon jug. Now the capacities, the water available in both the jugs is, in first jug you have 5, and then the second jug you have 2 gallons. Now apply eighth rule again. What does eighth rule tell you? You have to pour water from the first jug to the into the second jug based on the capacity. So there is 5 gallons of water in the first jug, there is 2 gallons of water in the second jug, and from 5 to 2, if you pour, what happens? You can only pour down 1 gallon of water in the second jug. Then how many gallons of water is left over in the first jug? 4 gallons of water in the first jug. So what is our goal? You should have 4 gallons of water in the first jug and any quantity of water in the second jug. We are not worried about the water that's available in the second jug, but the quantity of water that's available in the first jug should be 4 gallons of water. See, this is one solution. You applied the rules. See, what are the rules applied? 1, 8, 4, 6, 1. This is the sequence in which the rules have been applied. The same rule can be applied any number of times, and we have obtained the solution. And do not go with the wrong impression that this is the only solution available for us. See, there is another solution over here. Here, starting with rule number 3. What does rule number 3 tell you? You have to fill the 3 gallon jug. So initially the 3 gallon jug will be filled up, and then that the first gallon jug is 0. Next, apply rule number 5. What is rule number 5? You have to pour that water into 5 gallon jug. So what is going to happen? The 3 gallon jug will become empty, and the 3 gallons of water will be poured into this. Now again, apply rule number 3. That means fill the 3 gallon jug. So now both the jugs will have 3 gallons. Now apply rule number 7. What does rule number 7 tell you? What does rule number 7 tell you? You are pouring the water from, rule number 7. This is going to tell you pour water from the 3 gallon jug into 5 gallon jug. So again you are pouring water. Now this becomes 5 and this will have 1. Now apply rule number 2. You are emptying this 5 gallon jug and this still have 1. And now apply rule number 5. That means you are pouring this water into the 5 gallon jug. Now 5 gallon jug will have 1 gallon of water, and the second jug will have 0 gallons, no water. Again apply rule number 3. Now this will have 3, and the second jug will be filled up. Look at this. Now apply rule number 5. That means again pour this water into the 5 gallon jug. Now 1 plus 3, what happens? 4. Now what is the quantity of water left over in the second jug? 0. But did you reach the goal? See, we are not worried about the quantity of water that is left over in the second jug. We are only worried about the quantity of water that's left over in the first jug. So our goal state is reached. See, in the previous case, this is 4, and in the second jug we have 3 gallons of water. In this example, in the second solution part, we have 4 gallons of water in the first jug and 0 gallons of water in the second jug. See, this is how you can apply the production rules. So the important part over here is you have to define all the production rules of the production system for the given problem, and then apply those problems from the starting state. You can apply them. So you have to define a sequence of the rules. In which sequence, if I apply the rules, I arrive at the solution. Are you getting this? This is simple if-then rules. Don't get carried away. Simple, if you are good at your Python or any programming language, application of simple if-then rules. All these are rules. So if you apply these rules in that particular sequence, you'll be coming across with this solution. That's what this implies. Okay, Nama? So we'll go with a few more problems in the next class. Sorry, we are running out of time because you have some other class following this. And what I expect you to do is, how many of the students are there? 55 students, good number, but still 14 students are absent. In the meantime, CR, please post the attendance. I'll compensate. Hello, CR. Yeah, thank you. Thank you. And see, if I may have to take certain extra classes because what is happening is there are few disturbances from the management side. We have the committee, so I'll compensate. I'll tell you in advance and accordingly compensate the class. Please cooperate in this regard, okay? And what I expect you to do is you have to write down a simple Python program for this water jet problem. You to write down, see, I'm trying to give a different type of exercise. I'm not asking you to do the same kind of problem. You implement this because we do not have AI lab. This AI lab is important for your the placements. Try writing down a Python program to implement the water jet problem. You can simply write down the if-then statements. You simply write down the if-then statements, and you would be definitely getting a solution. Please try doing it. Please try doing it. Thank you, and please, it's 9:55. Please leave and join the following class. Thank you. Amma.